Well, hello. This week we're going to expand on what we did last week with SOHCAHTOA and hopefully make sure that you know why it's important to know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I've said in my classes at school today that typically I will go through this by drawing a bunch of triangles on the chalkboard and answering questions as we go along. That's kind of hard to do when we're trying to present things remotely, so that's why this is done with a PowerPoint. You may want to pause the PowerPoint in a few places and make sure that you understand what's going on before you go on to the next slide. So what we're going to talk about today is what's called solving triangles, which means finding parts that are missing in triangles. And typically when you have trigonometry problems, what's going to happen is you'll know some of the information from a triangle, but there's something important that you're trying to find. Like, for instance, the picture on the top right might be asking us to figure out the angle that an airplane had to take off at. Although I will tell you, if this were an actual airplane, it would be way too big of an angle that we're going to end up getting for the answer. Or you might want to find out how far away from the shore is the ship in the bottom picture. In all of these, we typically will have some angle that's marked. We know one of the sides, but we're trying to find something else. And to solve problems like this, we need to basically do it in two steps. What we're going to do first is we're going to write an equation that uses either sine, cosine, or tangent. You basically want to think back to SOHCAHTOA that we talked about last week. You want to think about the fact that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You'll look at the picture, see which sides are involved, and think, is this a sine problem, a cosine problem, or a tangent problem? So for instance, you might have an example that looks like this one. And you'd want to look at that and notice that the x in this problem is the hypotenuse. The 8 is right next to the 35-degree angle, and that means it's got to be the adjacent leg. And so I know this is going to be a cosine problem. When I write the equation, it's going to look like this. I have cosine, and then right after cosine, I put whatever the angle is. So cosine 35 equals 8 over x. And we'll talk about how to solve that in just a minute, but for now, you want to be able to look at that problem, recognize we've got adjacent and hypotenuse, so cosine 35 equals the adjacent side over the hypotenuse. Here's another one. In this problem, what we're trying to find is the angle, and we know the opposite side, we know the adjacent leg. Well, that's tangent, and that's why I would write something like tangent of x equals 300 over 400. Again, I always put the angle right after the trig function. Tangent x equals 300 over 400. And the other one that we were setting up ahead of time, I focused in on that 39-degree angle. 30 is the hypotenuse. D is going to be the opposite leg. And that's why this is a sine problem. It'll end up being sine of 39 equals D over 30. So on all of these, I want to look at the angle that's marked, think, are the sides that I know opposite, adjacent, or hypotenuse? Go through SOHCAHTOA, and like SO stands for opposite over hypotenuse, so I know that that's going to be the sine of 39 equals D over 30. Once I've come up with an equation, then what we have to do is actually solve the equation. And to solve the equation, you will need to have some sort of calculator that does sine, cosine, or tangent. Now, there are a lot of different ways that you can use calculators. When we're working in class, a lot of people will borrow the ones that I have up in front, which is great. Some people have their own calculator. I had some people today that were working on their phone. Especially if you're working with your phone, you first of all need to make sure that your calculator is set so that it's in scientific mode, so that it shows things like sine, cosine, and tangent. And then you need to make sure that it's measuring degrees rather than radians when it measures angles. There's more than one way that you can measure angles. And one way to test your calculator is to take just a second and type in sine 30 and then hit the enter or equals key. If your calculator's set the way it should be, when you do sine 30, it should give you an answer of a half or 0.5. If it gives you anything else, there's something screwed up in the modes, and you either want to see me at some point or look in some sort of instruction manual, see if you can figure out how to get things set so that it measures angles in degrees, because everything we do this year, pretty much we're going to measure angles in degrees. Once you have a calculator set so you can use it, then we'll talk about solving the equations. And there really are three different ways that you can solve trig problems. Which one you do doesn't have anything to do with whether it's a sine, cosine, or tangent problem, although you'll press the key that says sine, cosine, or tangent, depending. What it really has to do with is where the variable comes up in the equation. So one of the equations that we did earlier said sine 39 equals d over 30. I believe that was the last of the three that we set up. We actually had problems that looked surprisingly close to this on that last test that you had over the first chapter, because this has a fraction. And the way that you get rid of fractions when you're solving an algebra problem is you multiply. And in particular, what I want to do here is I want to multiply by 30. So what I would do to solve this problem is take 30 times the sine of 39, and we end up getting an answer that's about 18.9. Now, you could also take sine 39 times 30. That's fine too. The one issue that comes up if you do it backwards is an awful lot of calculators will put parentheses on the screen when you type like sine. And if you did that first, you need to close those parentheses before you put in times 30. You start with the 30 and just work backwards, you're always going to do it right and it will work out. So again, the answer is about 18.9. People will sometimes wonder, how am I supposed to round answers like this? Because they're always irrational numbers that go on like this one does. There's no hard and fast rule, but in general, if you round to tenths, to one decimal place, you should be good to go. So I would write this one as 18.9. And again, the key to this is when you look at your equation, if the variable is on top of the fraction, you multiply. So another thing that can happen is a problem like this one, cosine 35 equals 8 over x. Here, the variable is on the bottom of the fraction. And what's going to happen to solve this is we're going to divide. And in particular, what I want to do is take 8 divided by the cosine of 35. And my answer is, I would round it to 9.8. I do have to divide in that order. If you try and do it backwards, you're going to get some stupid little decimal that really doesn't make sense. Here, though, 8 divided by the cosine of 35 is 9.8. What's really going on when you solve a problem like that is basically you're cross multiplying. You're taking 8 times 1 equals the cosine of 35 times x, and then you divide by cosine of 35 to solve that problem. So again, when x is on the bottom of the fraction, the thing you want to remember is divide. X is on top, you multiply, x on the bottom, you divide. The third thing that can happen is you could have a problem that looks like this. The tangent of x equals 300 over 400. Here we're trying to find the angle. And when you try and solve for an angle, you want to look for a key on your calculator that says shift or second or inverse. Typically that key is in the top left-hand corner of your calculator. But what you want to do is, in most cases, press second and then the tangent key, and it'll put a symbol on your screen that looks like tangent to the negative first power. We actually read that as the inverse tangent. And then in parentheses, you type 300 divided by 400. What you're basically doing when you hit inverse tangent is you're asking your calculator to play Jeopardy. You're saying, I know that the answer to this is 300/400ths. I want to know what's the question, what's the angle that would make that happen? And it sort of looks it up in a table, finds out that it's about a 37-degree angle that has a tangent of 300/400ths. Now, some older calculators do work differently than these, and if you're having trouble getting yours to work, then contact me and let me know, and I'll try and get you pointed in the right direction so everything does work out properly. But again, if x is on top, you multiply, x on the bottom, you divide, and if x is the angle, you're going to use the inverse or second key to come up with your answer. So I want to look real quick at 3 more examples, and what I would suggest to you is, first of all, after I show the example, pause for a minute, see if you can figure out what the equation is, and then what you would have to do to get the answer. So here's our first problem. Again, see if you can think, what would the equation be? Does it involve sine, cosine, or tangent? And then what would you have to do to get the answer? And this problem, x is adjacent and 6 is hypotenuse, and that's why we do get the cosine of 73 equals x over 6. Since the x is on top, we would take 6 times the cosine of 73, and you get about 1.75 for a final answer. Here's the second of those examples. Again, see if you can think of an equation and what the answer would be. The equation this time is going to be a sine problem. Here the triangle is pointed in a different direction than we're used to thinking of, but the longest side and the side across from the right angle are always the hypotenuse. So here I've got, with opposite over hypotenuse, sine of 45 is 35 over x. We're going to divide to get the answer, and I do get an answer that's bigger than 35. That's what it should be. We end up with about 49.5 for the answer. Finally, the last of the problems that we need to look at would be this one, where I am trying to figure out angle B. The sides I know are opposite and adjacent. The 4 is opposite and the 7 is adjacent. So it would be tangent of x, or of b if you prefer to write it that way, equals 4 over 7. This is where we'll use the inverse or second key to come up with our answer. It would be second tangent and then 4 divided by 7, and it works out to be just about 30 degrees. So again, you got to write your equation with sine, cosine, or tangent. If x is on top, you're going to multiply to get the answer. If x is on the bottom, you divide. And if x is the angle, you use the second or inverse key. Tomorrow, we're going to have some problems doing exactly that, but that's the crash course in how to find missing parts of triangles.